All right, good afternoon. Welcome to what I believe is the last session of the day. We're going to talk about data extraction and sharing with the Delta sharing protocol. My name is Art Rask. I'm with Databricks. I'm the moderator. But the real star here is Roger Dunn, co-founder of Exponum. And yes, all right.
Thank you very much. Thank you all.
And I'll hand it over to Roger, but if there's any questions, we can use the mic so that everybody can hear, if we need it.
Cool. Thanks very much, Art, and thank you all for coming. Before we get started, I want to acknowledge my co-founder, Herman Weintraub, and because this session is likely to pack it in for the full 40 minutes, we're certainly available afterward to answer any questions that you might have. And also, if you need to run, then feel free to reach out to us, email, LinkedIn, whatever you want to do. We really want to inspire people to use the Delta sharing protocol and build really cool integrations. So let me just jump right in. At Exponum, we've used the Delta sharing protocol to build an Excel add-in that allows organizations to be able to share out data out of their Delta Lake infrastructure directly to their Excel using community. And we've been on this journey now for about 1.5 years, working with Databricks and just trying to really maximize the use of the Delta sharing protocol. And what I want to do today is basically share all those lessons learned so that if you're proposing to do that kind of integration yourself, you can, as this gentleman said, learn from our mistakes and lessons learned, and you'll get there faster, better, and it'll be awesome. So real quick, as an outline of what we're going to be talking about, I'm going to give a quick introduction to what Delta sharing protocol is all about. We're going to talk briefly about what our traditional expectations around data sharing is. Frankly, the Delta sharing protocol revolutionizes that. Revolutions sometimes mean that you have to rethink things, and we'll go through that. Then we're going to have a quick dive into what the protocol APIs are, what that API surface looks like. It's going to seem super easy and familiar to you, which is good because it is. And then we're going to get into the heart of the matter, which is 14 tips that I think everybody should know if you're going to move forward and do this kind of integration. The most important thing when you're going to take a journey like this, or really any trip, is to find a good starting point. And so luckily, there are 2 awesome starting points for doing this kind of integration. The first one I'd point out for you is go check out the open source initiative around this. It's on GitHub. Just go look for Delta sharing. I've provided the link there. The most valuable asset that you'll find in there, in addition to the reference open source server that you're able to use and use in your testing, is the protocol markdown document. Now, this is a pre-version 1 protocol. It's innovating really rapidly. It's got some awesome things happening in it. The markdown does get updated. You'll want to stay on top of that. Great place to start. Or if you want to kind of go to an even fuller reference, go to delta.io/sharing. There's a jump-off point there to GitHub. So if you only want to remember one thing, delta.io. And that's a great starting point for a trip. The next thing I just want to touch on briefly, because we are going to focus in this deep dive into the protocol itself, is why? Why does this matter? And the way that we view it at Exponum is that it's almost like a holy triumvirate that's formed around Delta Lake as a storage layer, Unity Catalog as a fantastic vehicle for governance and cataloging. By the way, how many people here are using Unity Catalog today? Okay. There's been a ton of announcements at this conference, a ton of sessions on all the innovations that are happening in it. It's really developing into a very full-fledged mechanism for applying that governance and management around all the artifacts that participate in your Databricks infrastructure. Strongly urge you to check it out. But those 2 things that basically allow you to organize your table-level data into the hierarchies that are meaningful to you and your data recipients, coupled with the Delta sharing protocol as a read-only access mechanism, is what basically powers this revolution of being able to share data across organizations. And we've been trying to do this. I mean, I've been at this for 40-something years. It's finally happening, and I'm living to see it, so I think that's pretty good. Now, we found at Exponum that as we entered into this journey, the first thing that we had to kind of disabuse ourselves of was the expectations that we had around traditional data sharing. And data sharing in the old way was kind of composed of mechanisms like ETL and so forth, and other things like EDI and various forms of exchange. And in that traditional view, there's always been the case that the shape of a result in a sharing environment conforms to the shape of a query. And that's a common enough thing to do, and we're used to this. And there's lots of declarative ways we could have done this, but let's just in a SQL sense, if I say that I want to select some columns from a table with a where clause, and I'm just throwing on a limit clause for the sake of example, we might expect that in fact, we'd count on the fact that our result conforms to the query. We will get those columns. We're not going to get row level data, where in this case, the filter predicate is not met, and we're not going to get more than 50 rows. We count on these things every day. We do this sometimes at our peril, that we open up that capability to declare these things, and users will bury the needle of our database stack. It happens. Now, if there's any one thing that I'd ask you to take away from this session, it's the knowledge that Delta Sharing Protocol comes at it from a different angle, and that it's a best effort approach to satisfying queries and to trying to have the results that conform to the query. Best effort, just lock that away. And in fact, I'd called out a couple of lines from the current version of the Markdown, that protocol Markdown that I mentioned. The first one is, when it comes to doing a table query, right verbatim, filtering files based on SQL predicates is best effort. The server may return files that don't satisfy the predicates. Second one, the limit hint, another capability in the protocol, is also best effort. And you may find the server returns files that contain more rows than the client actually requested. Let's think about that in a real world sense. Same select statement. What might our expectations be? What's the reality that's met? Well, you might actually get some row level data where, in this case, A is greater than or equal to 100. Surprise. And you may also get more than 50 rows back. And the really interesting thing, it goes to the title of this particular session, is you might or might not get columns A, B, and C, and there could be some other columns too. But that's just something to just kind of embrace, and I'm going to show you how to deal with it. And the most important thing I would call out is that what you'll find is, compared to the traditional mechanisms that you might have used, whether they're ETL, ODBC, JDBC, or other types of connectors, this underlying capability, this best effort approach, and all the things coupled in the protocol are what really allow it to deliver a much more powerful data sharing mechanism. And that is something that, as we found, you can exploit to your benefit. So as you're building out your connector, hopefully some of what I'm going to show will be relevant to you. The real challenge that we want to meet in this particular talk is to figure out how are we going to use the protocol to meet those data sharing expectations. And we'll start by just taking a quick run through the protocol. There are two basic, let's just start with some basic concepts. First of all, REST protocol, straightforward enough, implemented by Databricks reference data sharing, Delta sharing server, and also the open source server. But if you're using a modern Databricks environment, and I would urge you to speak to this gentleman here, Josh, if you have any questions about this, you will already have this. And it provides read-only access to cloud data sets that reside in your Delta Lake tables. Those tables participate in a hierarchical structure that if you use Unity Catalog, you'll already be familiar with. You have a Delta sharing server, think of that as your server or your host. It possesses 0 to many shares, which possess 0 to many schemas, which possess 0 to many tables. Straightforward enough. It's a nice way to organize the data that you care to publish. The tables themselves can either represent a single static snapshot representation of the data, or they can, using the change data feed, or as it's typically called, the CDF mechanism, that can be live data that's under some process of incremental or continual update. Super powerful capability. And actually, just another quick show of hands thing. Who here is using change data feed in any of your environments? Okay. As you get into more advanced use of your Databricks environment, it is so powerful. It's such a fantastic way to be able to project change sets into an environment from which they can be published out and be, frankly, trivially accessed using this protocol, as well as other forms of Databricks integrations that Databricks makes available. So CDF, if you've got things like tick data, IoT data, climate data, anything that's changing, and where you really want to see that live concept, you really want to look at CDF. In fact, while this session does not propose to be like a deep dive into the full stack of things available on Databricks, one thing I would call out is this conference has had a number of fantastic sessions on Unity Catalog, on change data, and in fact, one I would call out in particular, I urge you to watch because all these things are being recorded. You can go back and watch them. Spencer Cook from Databricks did a fantastic session yesterday afternoon talking about Unity Catalog, how to create shares, how to grant to recipients, and basically do a lot of the stuff that if you watch that and then kind of think about what we're learning today in that context, it'll come together and hopefully make a beautiful, beautiful image for you. So that's another part of the Delta sharing protocol. Security, how is access rights granted? There are two mechanisms in Delta sharing that we would talk about. There's D2D, which is Databricks to Databricks. That's not the focus of this talk because you're not going to use the Delta sharing protocol to do that. Then there's what's D2O, Databricks to the outside. That's where this protocol really kicks in. And for that, the authorization is granted via a bearer token. That bearer token, if you're using Unity Catalog to publish out your data using an activation link, it's a one-time short-lived URL that will go to somebody, and they'll get a .share file, which basically is the payload for the credential that includes the bearer token along with the endpoint and some other things that we're going to look at in a minute. The last thing is, all of this participates under the governance and cataloging capabilities of Unity Catalog. So maybe originally, if you were thinking about Databricks 1 or 2 years ago, you kind of think, well, there's Spark Compute, and there's Delta Lake, and then Unity Catalog. I'm kind of thinking of sitting on top, kind of an umbrella over those things. I'd flip that view today. I'm not sure if my Databricks friends would agree with me, but I see Unity Catalog as the cornerstone on which everything else is built. All the artifacts are managed through that, and the publication mechanisms are mediated by it as well. So crazy powerful way to think of things, and frankly, it's something the world has needed for a long time. Thank you very much for the innovations and the expansions to it that we've seen at this conference. So the protocol itself is broken generally into like two categories. It's a pretty sparse surface. The first one is the APIs that you would use to interrogate the hierarchy. You can find out the shares participating in a server, and within a share, the schemas, the tables within the schema, kind of straightforward navigation to be able to interrogate things. So if you're building a UI, for instance, where you want to be able to prevent navigation, as we do like in our Exponum Connect product, we want to be able to let people view navigation and kind of trivially select the data sets they're interested in, then you'll want to look at the hierarchy side of the REST API. And then you finally want to be able to look at the particulars on a given table. A couple of APIs that are really valuable there. You can learn the current version of it. Tables are versioned based on an incrementing int32, so that's great to know. You can also get the table metadata, which you'll really want, because that's the schematic content of the table. And finally, we get to the good stuff. You want the data. Two mechanisms, and the one I think you'll probably start with is the query mechanism, because that's the one that supports predicate hints, which if you're familiar with Spark data sources, correspond in a sense to like predicate pushdown type mechanism. Cool. Okay, so, and then the last one I'd point out is the changes mechanism. If you have a change data feed enabled environment or table, you'll be able to monitor the changes from one point to another using change data feed. So if you have like a fire hose blast of data streaming through, you can actually use the changes mechanism to do that. We'll come to this at the end of the thing, but just a little preview. Query allows you to specify things like limitHints and filter predicates. Changes does not. So you'd use them for different reasons, but that's basically the API. So we've kind of packed the car up and backed it up out of the garage, and now we're finally ready, after that very long-winded intro, to take the trip. We're going to start with a couple basic tips. The very first one that I'd have you know is that those credentials buried in the .share file can expire. This is a capability that you would put in place with the Unity Catalog. So if you were sharing something out with me, you might want me to have access for a week or a month or a day, or maybe infinity. And here's a couple of examples of the JSON payload of a .share file out of the open source server. And you see it's got an endpoint and a bearer token that, for brevity, I've omitted. Here's another share file that was emitted out of Unity Catalog. And you see this one has the expiration time. If you're building a UI where you're sensitive to that, where you want your users to know you had access to this particular connection to a Delta sharing environment, and now you don't, or you might want to give them a countdown that says you will be expiring in 5 days, or you have expired, maybe you want to give them a link to be able to contact their UC admin and be able to renew that credential. Just be aware that it's an optional capability of the share file, but when present, you could use to surface that kind of user mechanism. Second general tip I'd have you know is that some of the APIs support a pagination model. Now, you might be able to ignore this, at least in your initial implementation. Specifically, the APIs that are in question are interrogating shares, schemas, tables, and the all tables. All tables we can kind of glance over because it's simply a way of saying, give me all the tables associated with the share, which you would have already been able to do with the other ones. So pagination is really in place when you have a potentially unbounded result set and you might be concerned. You might be asking yourself the question, how many tables or schemas or shares might I expect to see back? Millions? That's a lot. But you might find is once you put your Databricks environment into production, you might actually have a large accumulation, for instance, of tables associated with the schema, and you might really benefit from a paginated approach. As a developer, the best news about all of this is that Databricks employs the same pattern across all those APIs for pagination. Basically, if you want to use it, and it is optional, you don't have to, you simply add a max results argument to your request, and then you'll get back a page token if there are more things than the window or page size that you've asked for, which you can then feed back as a next page token. And if, like I said, if you don't want to use it, you don't have to, you'll get a default result set, which is going to typically be the full result set. A simple example. Here's a request for tables associated with a particular schema, and you can see I've set the max results to 4. Now, I happen to know that there are 7 tables in this particular schema. So the response to the first one gives me the first 4. Great. It gives me that next page token that we mentioned, which allows me to then fetch the next page by appending that to my get string, and I, as predicted, get back the remaining 3 tables associated with that schema. The absence of a next page token tells me I'm done. I'm finished paging through the result set. How you choose to implement that on your side really depends on the kind of user presentation or data transfer that you're trying to equip. It might be you need some statefulness or whatever, but the key thing is that you can create a pagination wrapper around those 4 APIs and write the code once and benefit from it everywhere, which is kind of what we like to do, right? Now that we can basically interrogate hierarchy and understand some things about pagination, we're ready to actually query and get some data. So let's talk about some tips around that. And the first thing I would say is that you're going to want to rethink what you mean when you say query. I found I had to. A Delta sharing protocol query is not the same as a SQL select. And we've already talked about some overfetching, underfetching capabilities, but it's really more fundamental. We're all used to using interactive SQL tools, right? So we submit a query, we get back a result set. With the Delta sharing protocol, when you submit a query, you get back several lines of text, each of which represents its own JSON payload. The first one is always the protocol, which we'll kind of glance over. The second one is always the metadata, very useful, tells you the schematic content of what you've queried. And then there will be 3 to n lines, each one of which is a file descriptor. That file descriptor has a number of attributes that we're going to be looking at in more detail, but probably the most important one to you right now is that it has a short-lived URL to the Parquet file residing in cloud storage, like for instance in S3, from which that Parquet file can be downloaded and then worked with. So a query, in the Delta sharing sense, isn't the result set. It's the mechanism from which you can begin deriving the result set. Okay. The next thing I would say is now that we've kind of worked our way up to the point where we're going to be able to issue a query, we're going to get some paths to some Parquet files, is what do we want to do with them? And there's some details there. You might have to point out that there are some type alignment issues between what Delta sharing tells you the schematic content is and what's available in the actual Parquet file. Delta sharing supports the notion of nullable columns, which you would think of as optionals. And those might or might not work the way you expect. And then depending on which kind of Parquet row or column reader you're using, and there's a number out there, there are certain quirks and behaviors that you'll find to be a little daunting. For the next bunch of slides, I'm going to be showing dumps of Parquet data and viewing it relative to its corresponding delta sharing representation. There's a little open source tool that we provide called Parquet Inspector, which is our way of being able to do this. If you're developing an integration like this, you'll want something like this. Now, there's a lot of great Parquet tools out here, but we really wanted one that helped us understand that alignment better. So you're welcome to use it, critique it, do whatever. I'm going to show you 4 examples of what I'm talking about. We got Parquet, we've got delta sharing. They both are going to present us with the schematic content of the answer to our query. In this first example, we're looking at a table that's not partitioned, doesn't have changed data feed, it's just the most vanilla of tables. It's got 6 columns. You can see the first 3 in terms of Parquet schema are binary with string treatment. We've got 3 int32s. They're all optionals. Life is good. And sure enough, the delta sharing schema directly out of that line 2 in the query response tells us an answer that really aligns with it. I mean, we can see the types, strings and integers. We can see that they're nullable columns. It matches. And sure enough, if we look at the data dumped out of using that little Parquet Inspector tool that I mentioned, yeah, it's pretty much what we expected. Now, if, like me, you developed that and thought, I'm done, and put it into test with a whole bunch of different tables, expecting it to work, you too will be very surprised. And let's look at another example as to why. This particular table, similar, not partitioned, no change data feed, but it does possess both null and nan type characteristics. So the delta sharing schema in this case, when I first viewed it, I saw this, what I thought was an incongruity, which was the date column this time for this particular table is configured to be of type date. In terms of the Parquet data, you see that's an int32. It's not a date, it's an int32. And what's the deal with that? We look at the actual data, and we can see in the date column on the left a bunch of ints, as promised. We also see a bunch of not a numbers on the 2 optional float fields. Well, what's happening there is that the Parquet row reader in question didn't know how to deal with an optional of a primitive. It's a primitive. So its interpretation of the primitive was, it's a null value, therefore it is, by definition, not a number. If I had naively stopped at this point, I'd be showing finance people and accounting people a bunch of columns with a bunch of nans. That's not cool. So look at the response, figure out what that means in terms of user presentation. We choose to leave those things as empty fields because we know the meaning is it's empty. You might want to put a hyphen or not applicable. Do something that makes sense for your user. And also understand what is that date. And the answer there is that date is an epoch date, right? So you need to basically transform. You just need to know what it is. This third example goes a little further. Now we're going to look at a table on which partitioning has been applied. It has just one partitioning column to kind of keep the example simple. And it's, in this case, it's the date column. We have the Parquet schema, straightforward enough. It's got a bunch of columns. But when we look at the delta sharing representation of schema, we see it possesses a date column. But it's not in the data. And what's going on with that? And is it just underfetching? And the answer requires us to take a deeper look at the response that we got to the table query. And what we'll see when we look at that second line that possesses the metadata for that table query response, we'll see that there are partition columns. In fact, there's a partition column called date. And when we look at an individual file descriptor, in this case, the third line of that response, we'll see a new optional attribute, which is the partition values. And sure enough, it has a value for date of December in 1999. The actual raw data in the Parquet, in fact, does not possess that date. So what's incumbent on us as developers is to be able to synthesize a table and apply for this particular file the column values for date equal to December 22nd, 1999. So all of a sudden, it's getting a little more nuanced. You have to look at more things before just projecting the answer that's conformant to the request. We'll look at just one more example, which is, what's the deal with change data feed? So this is a table for which change data feed has been applied, and we have a Parquet schema, which at first glance looks like it's totally reasonable. I see a bunch of columns that I might expect to see. And then we look at the delta sharing schema for it, and something jumps off the page, which is that Parquet schema has a column that's not in the delta sharing schema. Now, I don't know about you, but I grew up in an age when Bertrand Meyer was coming out with the idea of like strong contracts and the Eiffel programming language, and you assert preconditions and you assert postconditions, and if you either succeed perfectly or you fail utterly and you throw an exception. So when we were writing this code, we believed that the delta sharing schema says this is the schematic content of the data. Therefore, if that's not what's exactly in that Parquet file, then everything must be wrong. Because we didn't realize that if it's a changed data feed table, that column is going to be in there. So it's not actually overfetching, it's just unexpected. So you have to kind of relax your assumptions about what things are. And I'd say this because otherwise you might proceed with unit test and all of a sudden find that you're blown out of the water. And sure enough, if we look at the actual raw data, we'll see that there is that extra column. Another thing to be aware of is marshalling. There's just a couple of types that need a little love in terms of type marshalling. We touched on date. Obviously, it gets int32 treatment. It's just epoch date. And the other one is if the delta sharing schema indicates timestamp, what you're going to get into Parquet is an int96. Now, the int96 is basically, you break it apart, and you can get the Julian day and then the time of day in terms of nanos within that. And if you really want to look at how to understand that, I just point you to the Parquet Write Support Scala file inside of open source Spark, and you can immediately jump to how that is assembled and treated. But if you're trying to present a timestamp to a user and what you got was an int96, you're not done yet. We've understood something about the form of the data. Now we really want to do some interesting things with queries. We want to filter the data. This is super important for most presentations because your backing data in Delta Lake could be vast. I mean, how many people here have a data set that's like 1 million rows? Anybody? Okay, 10 million? How big? 200? 270 million. Okay, so you might not want the user to get all of that, so you need to have some concept of filtering. And honestly, Herman and I regularly run into billion-row data sets and beyond. I mean, Databricks is an unbelievably powerful, scalable platform, so expect that data consumption could be through potentially a very big pipe. So when it comes to filtering, there's a couple of things you need to know out the gate. The first one is you can't rely on limitHints. We showed that at the beginning, but let's look at why. It's a best effort approach. The open source reference server doesn't apply them at all. But the Databricks environment that you'll get in a Databricks infrastructure actually does do a pretty good job of it. It's not a perfect job. But the bottom line is, as a developer, you can't count on the limitHint. You have to do a little work yourself. And let's look at why. In this particular case, I'm issuing a table query where I've specified a limitHint of 4. I just want 4 rows back. Now, the response I get from the delta sharing protocol in this case is a couple of file descriptors. And the first one indicates that I've got 2 rows of data in that Parquet file. The second file descriptor shows that there's 3 rows. I asked for 4, I got 5. But I didn't get more. So it really did make a best effort. But if you're doing something where you're trying to allow users to page through data, maybe in this case 4 rows at a time, which seems ridiculous, you probably need to somehow intermediate between the responses that you're getting and what you're presenting. Second thing that I want you to know, again, if there's only one thing you walk away with, it's best effort, is that you have to apply client-side filtering. Now, a really cool thing about the Databricks reference environments for this is that not only is delta sharing by itself something where there's no DBU implications, right? It's pure file transfer. But as we've learned working with our friends at Databricks, if you do enable filter predicate application on the server side, which to be honest, most people do not do yet, it doesn't incur DBUs. So filter predicates in your queries that you form may be applied, but you won't know that as on the client side of the API. So what you'll see is overfetching. And here's an example. In this particular case, I've supplied a predicate hint for a particular date of June 26th this year. And the response that I got back, just looking at the first file descriptor and looking at the stats for the information within that Parquet file, is minimum and maximum dates for that date column that are back in March. So clearly, the filter predicate was not implemented or performed server-side. I have to be able to do that work myself. Now, the Parquet data behind the scenes actually bears out exactly what I said. When we look at the Parquet that actually came in, we see the epoch dates forms as integers, and that little screen snippet at the bottom of Exponum Connect, we can actually say, yeah, sure enough, those were dates in March, exactly as promised by the stats. So you got to do the filtering yourself. Now, the way to use filtering, at least a starting point, is to really leverage those stats, because you'll perform less compute client side, and you'll ultimately deliver a much crisper user experience. In fact, depending on how you do this, you can make things run really beautifully. So let's think about that stats thing that we referenced a moment ago. Every file descriptor that's returned in that query, table query response includes an optional stats entry. Now, it is optional, so it can't count on it. But if it's present, what it has as values are the number of records in that Parquet file, the min values and max values and null count for each column. If you choose to use this, you can skip files entirely that don't match your filter criteria, which is really cool, because you can avoid downloading the Parquet file, so you can limit egress costs, and you can really speed up the query response. So let's look at an example. Here's a query, straightforward query with the stats populated. Almost illegible. I'm not going to ask you to look at that, so here's a little table that kind of summarizes that. For each column, I present the min, max values and the null count. Based only on this, if you had, for instance, somebody who said, I'm interested in a date of like January 15th, 2021, well, you know it falls in the range. If they said, I want FIPS of less than 100, you know you can rule that file out. If they said, I want to see where the county is null, well, you know there's 0. You can skip the file. So you'll want to be able to implement your client-side filtering not only on row-level data, but on stats data as appropriate for you. That said, sometimes you just can't avoid having to filter. There's limits to everything that I just said. If the stats are missing, and also if your filters that you've chosen to implement simply aren't informed by what's available in them. In our Exponum Connect product, for instance, we do a lot of value add on string treatment and date treatment. Like with strings, we support case-sensitive and insensitive filtering. That's simply not part of the protocol. We also have predicates that include strings begin with, ends with, doesn't contain, that kind of thing. It's not part of the protocol. But that's actually kind of cool, because what it means is that delta sharing as a data sharing mechanism is delivering you the data for you to be able to apply whatever filter semantics are meaningful to you. We've chosen to implement things that we think are common to business users, but you may have some things that are specific to you. For instance, calculated columns, where the protocol isn't going to know that, but you could do the filtering client side in any way that you choose. And that actually is very powerful. So with just a little bit of empathy for your users and a little bit of thoughtful design, actually this client-side filtering is an extensible mechanism that allows you to deliver potentially a much more powerful user experience. We're trying to use all these tools to deliver fast response, but we also want to be mindful of the cost of what we're doing. That stats mechanism that I just described is a way to avoid unnecessary downloads. And honestly, I've said this to people in the past, and I said, yeah, does it really matter? Well, it kind of matters, because it takes a time greater than 0 to download something, but also is a cost greater than 0. And even though data egress costs from cloud providers typically are low, they're not 0. And once you have a lot of users using the data that you're publishing out of your Databricks environment, you want to contain those costs. So this is a way to do that. You can limit the number of initial rows by implementing the mechanisms around limitHint that I described. You can use stats to avoid unnecessary downloads. You could also take the Parquet data that is downloaded and cache it on some caching basis that's meaningful to you. They are immutable once down. So every one of them comes down with a UUID. It's durable so that you can count on it from query to query. So if you've already downloaded a file and cached it, you're already done. No additional data egress cost and no time cost. So those are just things to think about. Now that we've kind of been through basic query and kind of the conformance of shape and of result versus the query itself, we're going to look at some things around change data feed. Now, I realize that only one hand went up when I said change data feed, but I'll bet you if we come back and do this again in a year, and let's have a party, let's make it a little more fun, I'll bet you all of your hands go up because it is that powerful. It's crazy great facility. And you're going to want to know some of these tips. The first one is that when you're querying for changes to a CDF-enabled table, you can get some unexpected HTTP errors. They will not make sense to you at first, but hopefully this will help clear that up. First thing that I would say is table versioning does not start with 0. So if you have a change data feed enabled table and you're saying, I want to look at version 0, then 1, then 2, then 3, then 4, and I kind of want to understand what happened to the data over time, if you start with 0, you'll get an unexpected result. What you'll get is a 403, and you'll wonder why. Similarly, if you query for a table version that's greater than the current version, you'll get a 400 error, and you'll kind of wonder why. So let's look at an example of this. So I'm going to fetch just a normal table query where I've specified a starting version, in this case, of 0. Now, I actually thought they really did begin with 0. I was disabused of that. I got a 403 that said you can only query table data since version 3. I didn't quite understand why. I hadn't really thought it through very well. So I went ahead and I queried for version 3. I got back happily a 200 with a good response. Life was good. I wanted to look at change over time. So I looked at 4. 4 was good. Then I looked at 5. Did a request here starting version of 5. I got back a 400 this time. And what it told me is I can't time travel Delta table to version 5. The available versions are 0, 4. Now, that's a little cryptic because I already tried 0 and I got a 403 error. So what's going on there? And the answer is there's a little bit of a mismatch between the response that I got and what actually happened in that Delta Lake environment. A vacuum command had eliminated versions 0, 1, and 2 if they were ever there. And you actually can't time travel back to something that's been removed. So it really now does begin with 3. So as you're trying to align your understanding of that response, that it looks like it can go from 0 to 4, it's really not true. So if you're doing something where you're trying to understand change and you're iterating through, just keep accepting those 403s, keep going to a next version, wait until you get to a 400. You can also query the current version, but again, it's change data feed, so when you query the version, that's only good for that moment. It may well have changed since then, so you just need to be sensitive to that. Everything I just said, I want to flip on its head. What happens if I query for change on a table that doesn't have CDF? And this, too, can lead to some very interesting, improbable results. I can request a table version, but if I try to query for a table as of a starting version, it will fail. So here, let's look at an example. I'm going to query a table version on this table called IPO calendar, and I get back that the Delta table version is 3. I don't know anything more about it other than it's version 3. However, I can say that if I ask for the starting version of 0 because I want to iterate through it, I'll get a 403 error. I simply can't query for version 0, 1, 2 based on the information that's available. I'll get a history fail. This will lead you, as it did for us, to be able to answer the question, if I'm going to try to walk the history of a table, was CDF enabled? And the good news is you can answer that question through the table metadata. There is a key for doing that, but you better check for the existence of that key. Don't assume it's there. And it's available via the metadata API. So here we are looking at the metadata associated with a particular table, and you see the optional configuration dictionary. It possesses an enable change data feed attribute. The value happens to be true. So if all those things are present and true, you got CDF, and you can do some of these version by version analyses. Otherwise, you'll just get the types of errors that I described. Very last thing I want to close with is that there's a difference between query and changes. Query, as I said, allows you to supply filter predicates and limits. Changes looks at discrete changes between versions. So this kind of lays out what some of those differences are in terms of the optional attributes you can specify. I think the changes API is super powerful, especially being able to specify either a starting and ending version or starting and ending timestamp. However, you'll get the full data payload. So if predicate filtering is enabled on that server, it's meaningless in this world. So that's just something to know as you're thinking about how you're monitoring change. Anyway, I know this has been a little bit of a blast. More than welcome to talk you through any of the details if you're interested. And I hope that some of what we've uncovered in our integration, which has been actually, to be honest, a complete delight to do, will help you in whatever you propose to do. And finally, because a trip like this never happens without a lot of help and a lot of advice, I just want to acknowledge a few people who've been absolutely instrumental on our journey. At Databricks, Itai, Josh, Tim, Will, Denny, and actually many others have been unbelievably generous with their time, their knowledge, and their commitment to our project. And also we have industry leaders, Bill, Subhash, Tori, and others who have been absolutely vital in helping us understand the type of user journeys they want to present. So we're both very humbled by everything that they've done for us, and very, very grateful. So thank you. I realize I'm at time. Happy to answer any questions after this, and thank you all for coming.